Let's look at an example 4.19. We're interested in the heart weight of cat, which is Y variable, and the body weight of cat is believed to be the good predictive variable X. For the heart and body weight, they have high correlation. The data consists of 144 dead cats. Their hearts and body weights are recorded. So we decided to use stratification based on the gender of cats that could lead to two homogeneous subgroups. So rather than just look at all the cats together, we think that the gender could be a good separation of the cats. And within the male groups, they are more homogeneous. And within the female groups, they are quite similar to each other. And between the male and females, they're quite different. So that's why we think that using a stratification could be a good method rather than just simple random sampling. And we decided to use the separate and the combined regression estimator to find the 95% confidence for the true value of the population Y bar. So let's look at the data that we're given. For the male group, there are about 97, females 47 of cats were given. Under the weighting is about 2/3 and 1/3 of them. Even though in this question we were not given the population weightings, we were given the we were not given the population size, but we were given the weightings, and the true value of the average of the body weight is 2.85 for the males, 2.4 for the females, but within our sample that's 2.9 for the male, 2.36 for the female, and SX square for each of the group were given. And we look at the heart weight. In the sample, the male group is 11.32, female group is 9.2, and we're given SX square, SY square, and also SXY. Under the separate method, first of all, we want to look at the male groups Y bar estimated under the linear regressions estimation. Then we can add up together with the females, but weighted by their population weighting. Okay, so under the male group, the beta is divided as SXY divided by SX squared, so it's about 4.3126. For the female groups, it's around 2.63644. We can see that from the very first observation, the beta for the male groups is quite different from the female groups. So we can say that they are quite different to the strata. Then we can add up the Y bar separately for the male and the females, weighted by their population weighting. For the male group, we use our sample Y bar minus the beta multiplied to the difference between the sample to the population. So Y bar under linear regression separate method is around 10.5. We can estimate the variance of the point estimate by looking at the variance. Again, under the linear regressions, we can estimate we can find the estimated variance of Y bar equals to 1 minus rho square multiplied to SY square over the sample size, and then weighted by the population weighting square. So in this case, the estimated variance is around 0.1187 square. For the combined method, we were given the overall X bar is 2.75. Then, first of all, we calculate the Y bar under the stratifications. So that is weighting, we can add up the sample Y bar for male and the female by the population weighting. So the Y bar estimate is about 10.61. X bar estimate is about 2.72. But we need to apply the linear regressions estimation for the sample to estimate the overall Y bar. Okay, so in this case, we want to use Y bar minus beta multiplied to X bar minus the true population value. So the question is how we estimate the beta. Beta is the weighted average of all of the beta between the male group and the female groups, weighted by Q. Q is indeed, by the lecture notes is given, Q is equals to the final population correction factor multiplied to Sx square over the sample size multiplied to the population square. So if we substitute that, we find that the QM for the male group is about 0.096. The Q value for female is about 0.000173. So in other words, we can estimate the overall beta by adding up the beta for male multiplied to the factor Q plus beta for female multiplied to the factor QF and divided by the summation of the weightings. So overall beta is around 4.3. So we can quickly compare the two beta. Beta M is 4.31. Beta female is 2.63. And because of the weighting of a higher weighting for the male groups, given the sample sizes and the variance. So we would have a higher weight for the beta towards the male group. So that is closer to the male's beta. So using this overall beta 4.3, we can substitute into this formula, or here, we find the linear regressions Y bar under the combined method is about 10.74. And again, the estimated variance of my point estimates is equals to the estimated variance under the separate method plus the summation of Q I multiplied to each of the beta difference to the overall beta square. So in other words, we can find that the QM is about 0.096 multiplied to the male beta, which is 4.31, subtracted to the overall beta 4.3, take a square, plus QF, which is 0.000173, multiplied to beta F, which is around 2.6364, minus the overall beta 4.3 square, and that would be a slight additional variance, which is around 0.000496 added to the estimated variance under the separate methods. So under the combined method, the estimated variance is slightly higher than the separate method. Okay? So we would say that the separate method would always be more efficient than the combined method under the stratification for the regression estimation.